Okay guys, what I'm going to do in this video is run through the capacitor lab with you, just very briefly giving you a few notes for each of the different parts of this lab. This lab is pretty straightforward, but there are a few details that you might end up skipping if you skip this background theory section, so make sure you go through it. We're using two different formulas, but this formula right here, you need to know all of its parts in order to know what we're changing when we go through these parts, right? So for example, we have our dielectric constant K, right? It's different from the K we used in our electric field kind of measurements for our constant. Here, this dielectric constant K, this sort of Greek K value, is 1 for vacuum, but it can be other values for things that we insert into our parallel plate capacitors. So let's take a look at this. We have here a simulation you're going to use for our capacitor lab, and it's got a few different options on it, right? So you can control the separation by dragging this up and down. You can control the plate area by dragging this in and out. You can disconnect or connect the battery here. You can change the voltage right here. But in terms of, so that's all for the control parts for setting up things. And then there are different parts of the lab where you're going to be disconnecting the battery or connecting it. So that's important for you to be able to do, right? So for example, if I have a battery hooked up and then I disconnect it and then I change my plate area, my separation, that's different than if I have my battery connected the whole time and I change my plate area and separation, right? So be careful with this, the steps. Make sure you don't make sure you don't skip any. Go through and select all of these things, right? So there are also just a few questions here, like here. You'll just answer them right as you see them. There are only a few questions in this lab. It's mostly just filling out here the process, right? So this comes from PHYS, right? So we've got here, we've got a lab where we are doing either, so we're going to check what we think will change when we change, let's say in this one, we're going to change the area of the plates, right? So if we change the area of the plates, then what will change? Will our capacitance change, the charge on the plates, the voltage, the electric field, the energy stored, all of these things? What will happen, right? And so you're going to just check these things. Don't worry. I mean, if you're completely wrong, that's fine. That's part of this exercise. And then you're going to, afterwards, you're going to come back and predict what actually changed. Okay. In addition, you're also going to try to predict which directions will the electrons travel, right, while you're increasing this area. Okay. So this is mostly of like a predict, right? Predict what's going to happen and then see what actually happens, because sometimes it might be a little bit counterintuitive, right? So capacitors are very important applications of storage and release of energy, right? But they act sort of in ways that might be a little bit non-intuitive. So coming in here, we've got our dielectric constant. So there's nothing in between these plates for this first one, right? So here, you know, we're going to have just vacuum in our plates. And then these values here will all come from your simulation, right? So we have our stored energy, okay, will be in this little meter right here. You can check these boxes to get all this information. Our stored energy will be here for you, okay? And then we have our capacitance, of course, will be here, this bar here on the left. We've got our voltage, which comes here from our battery. We've got here our charge, which is going to be here. Just be careful with the units. These little pico units mean times 10 to the minus 12, right? That's what our pico this prefix means. So when you see that, it's already including times 10 to the minus 12, so you don't have to write it in here, because you'll see like this is times 10 to the minus 13, so just kind of adjust that for times 10 to the minus 12. Okay, so The other thing that we have here is we've got electric field. In order for you to measure this electric field, you check this box for your electric field detector and make sure you put this in between your plates, just like it's shown here. If you do this, then it'll show you what the electric field is right in here, right? So we've got, our voltage across the plates, we've got our electric field, and all of our information should come from this simulation. So you shouldn't need to do any calculations here. And in this case, you can see what we're doing is we're starting with this 100 area and we're changing to 400 and seeing what happens, okay? And of course, we've got just another little question to answer. And as you go on, you're going to go on to this next step, and now you're going to be disconnecting the battery, and you're going to do this similar exercise, except you're going to keep the battery disconnected. When you keep the battery disconnected, now what do you think is going to change if I change any of these things, right? So you're going to do the same example, except now when you go from 100 to 400, you're not going to have your battery connected. Okay, and then you're going to answer here, what's the difference between these two things? So what actually happened when you change the area? Okay, now we have, you're going to change the separation now. Same kind of exercise, except now you're changing the separation. Okay, again, battery connected and disconnected. Now, so you'll see here we're keeping a 400 on our area, but we're changing the separation of our two plates. You drag those up and down, right? And then the last one is we're changing our dielectric, right? So this is the last section where we're going to change our dielectric material. This all it means is that you're going to put a block of something that is not vacuum in between your plates. So when you do this, okay, you actually change the way your capacitor acts, right? So this is part of that formula of how much charge can be stored. So here it gives us our values of what will be the different dielectric values, right, of something not inside, this block not inside, and then the block completely inside, okay? And then these same values we're recording to see what changes before and after this change, right? And then same thing, you do this disconnected and connected, right? So it's 6 sub-parts, but each part is really straightforward, kind of easy to go through. So I know this lab looks long, but it's actually not that long. And then we just got a few discussion questions here at the end, right? So hopefully this helps you guys out, just in case you get stuck on any of these parts, okay? Of course, if you're still stuck, don't hesitate to let me know.